Welcome to Comfort Learn classes. In this series of videos, I will solve previous year questions, NCERT important questions, and few questions from the sample papers from the chapter Continuity and Differentiability from PU second year. If you have any specific questions to be solved, either from some reference or from NCERT, you can just put it in the comment section. Let's start with the first question. Find the value of k so that the function f is continuous at the indicated point. So now here again the function is continuous at x is equal to pi by 2 and you are asked to find the value of k here. So here the difference between the previous question and this question is, in the previous question we used to have x is greater than or equal to 1 or x is less than 1. So now in such case we used to get LHL and then RHL, that is the left hand limit of the function and then right hand limit of the function. But here it is given x is not equal to pi by 2, right? If x is not equal to pi by 2, then the value of the function is k cos x divided by pi minus 2x. What does it mean? So here if you take this as a x, okay, if x is not equal to pi by 2, that is if x is either LHL or left hand limit, or that is if you approach this x from the left hand side or right hand side, okay, that is if x is less than 0 or if x is greater than 0, then the value of the function is k cos x divided by pi minus 2x. If the value of the x is pi by 2, then the value of the function is 3, right? First try to understand the function. See how the function is defined here. If x is not pi by 2, then this is the value of the function. If it is pi by 2, then it is 3, right? If x is less than or greater than pi by 2, this here. If it is pi by 2, 3. And it is continuous at x is equal to pi by 2 and you are asked to find the value of k. Fine. So again, LHL, or here LHL and RHL are not required. Directly you can take limit x tends to pi by 2, f of x is equal to f of x. Okay, don't take LHL and RHL, directly you take limit x tends to pi by 2, right? What is x tends to pi by 2? Either it is greater than pi by 2 or less than pi by 2. F of x is equal to f of x. So now let me find this LHS separately. Okay, let me take limit x tends to pi by 2, f of x is equal to limit x tends to pi by 2. The value of the function is k cos of x and then pi minus 2x. Okay, now how to simplify this one? See here, if you substitute x is equal to pi by 2 here, see what we get. So if I take x is equal to pi by 2, I will get k cos of pi by 2 whole divided by pi minus 2 times pi by 2. So k into what is cos 90? Cos 90 is 0 and then pi minus pi, which is again 0 by 0. Okay, so now here the limit is in 0 by 0 form, and we all know if the limit is in 0 by 0 form, you can use L'Hospital's rule. What is that L'Hospital's rule? You can take the derivative of numerator and then denominator separately. Okay, if it is in 0 by 0 form, you can take the derivative of the numerator, derivative of the denominator separately. So what we get here, limit x tends to pi by 2. Okay, now what is the derivative of k is a constant, you keep it as it is, and then derivative of cos is minus sine x. Okay, and then whole divided by pi constant, derivative of constant is 0, minus 2x, derivative of minus 2x is minus 2. Now you substitute the value of x in place of sine x here. So what we get here, if you make a substitution, then we are left with k, or you can take minus k sine of pi by 2 whole divided by minus 2, right? So then we are left with k by 2 into what is sine of 90? Sine 90 is 1, so that is k by 2, right? So that is our limit here. And what is f of pi by 2? F of pi by 2, that is 3 here. Now you equate these two. Equate this k by 2 to 3. So then k by 2 is equal to 3. That gives k is equal to 6 here. Right? So now if the function is continuous at x is equal to pi by 2, then the value of the k is 6. Let me solve one more similar question. F of x is equal to kx plus 1, f of x is equal to cos x, right? So two different values for x is less than or equal to pi and x is greater than pi. Again here it is given that the function is continuous at x is equal to pi, right? So the function kx plus 1 cos x is continuous at x is equal to pi, and you are asked to find the value of k here, right? So now here the value of x for less than pi and then greater than pi is given. So now here you can take LHL and then RHL. Okay, LHL is equal to RHL. So now let me find the LHL separately. That is limit x tends to LHL less than pi, or you can write pi minus x tends to pi minus, that is less than pi. Then what is the value of the function? Limit x tends to pi minus. If it is less than pi, then it is kx plus 1. Now you make the substitution. What we get here? K into x is pi plus 1, that is pi k or k pi plus 1, right? So this is my LHL, and you find the RHL. Limit x tends to pi plus, that is greater than pi. And then what is the value of the function if it is greater than pi? If it is greater than pi, then we have cos x here, cos of x. Now you make the substitution. So we get cos of pi. So and what is cos of pi? Cos of 180, that you get it from the unit circle if you remember from this view first year. So 180 is, if this is a reference line, we have 180 here, and at this point what are the coordinates? The coordinates of this point are -1 and then 0, right? And we all know the first coordinate gives the cos function, and the next one gives sine function, and as the angle is 180 here, cos of 180 is -1. All right. So now this is my RHL, right? And LHL and RHL are same, so you can write pi k plus 1 is equal to -1. So then pi k is equal to -1. If you take it here, -1 -2, or you can write the k is equal to -2 by pi. Okay, LHL, RHL, and then equate. And here you need to remember this value, cos of pi. I know most of you will be stuck with this cos of pi because you don't remember the trigonometric functions from the PU first year. We need to find the value of a and b, and it is given that the function is continuous. So first let me define the given function here. If the x is less than or equal to 2, if x is less than or equal to 2, then the value of the function is 5, right? And if the function, if the x value lies between 2 and 10, that is excluding 2 and then 10, right? If this is the x, then the value of the function is ax plus b, right? So if x is greater than or equal to 10, then the value of the function is 21, right? So this is how the function is defined, and it is given that this function is continuous, and we are asked to find the values of a and b. So for such questions, first let me take the point 2 here, right? Let's take at point 2, at point x is equal to 2, we know that the function is continuous. As the function is continuous, LHS is equal to RHS is equal to f of x, right? So now let me take just LHS and RHS. Let me equate these two, see what we get. So here LHS, not LHS, LHL, left hand limit and then right hand limit, right? So left hand limit and then right hand limit. So let me take the left hand limit. So here limit x tends to 2 minus. For left hand limit we get a negative sign here, right? What this negative sign indicates, it's a direction, right? This 2 is approached from left hand side, right? And we call it as a left hand limit, and let me take f of x here. So now here limit x tends to 2 minus. If the x is 2 minus, that is less than 2. If x is less than 2, then the value of the function is 5. So it is a constant function. Then we get LHL is equal to 5. So next, let me take RHL, right hand limit. And how we find RHL? Limit x tends to 2 plus f of x. What is 2 plus? More than 2. If x is more than 2, then the value of the function is limit x tends to 2 plus, here we have ax plus b, right? So now you make a substitution, right? Take 2 in place of x. So what we get here? 2 times a plus b is the RHL. All right. So now here we know that LHL and RHL are same. So now you equate these two. So what we get? LHL is equal to RHL, and phi is equal to 2a plus b, and you take this as equation 1, right? Okay. So now similarly what I will do, I will take at point x is equal to 10, right? Let me consider this point here, and again the function is continuous. So LHL is equal to RHL, and then what is LHL? Limit x tends to 10 minus f of x, and what is RHL? Limit x tends to 10 plus f of x. Now you substitute the value of the function. What is 10 minus? Less than 10. If x is less than 10, then the value of the function is ax plus b, right? Limit x tends to 10 minus. So here if x is 10 plus, that is greater than 10, then the value of the function is 21. Now you make the substitution here. So what we get? 10a plus b is equal to 21, right? So now this is the second equation, right? So at x is equal to 2, LHL is equal to RHL. We got first equation. At x is equal to 10, again LHL is equal to RHL. We got the second equation. So now here we are asked to find the value of a and b. So now you take these two equations, solve, and then get the a and b values, right? So now how to solve these two? Let me take the first equation, 2a plus b is equal to 5 here, and then we have 10a plus b is equal to 21 here, right? So you can use the elimination method. Let me cancel out these two, and then here we get minus 8a, and then here we get 16 minus 16, right? So then a is equal to 2. Now you make the substitution. Phi is equal to 2 into 2 plus b. So 5 is equal to 4 plus b, and then b is equal to 5 minus 4, that is 1, right? So that's how we got a is equal to 2 and then b is equal to 1 by using the concept of continuity. Find all points of discontinuity of the given function. So here the function f of x is equal to sin x by x if x is smaller than 0, and x plus 1 if x is greater than or equal to 0, right? So now here same, first let me define the function. So here let me take 0 here for x less than or less than 0, okay, excluding 0. If it is less than 0, then the function is sin x by x. If it is greater than or equal to 0, then the function is x plus 1. So this is how the function is defined. So now whenever you check for the continuity or the points of discontinuity, first you need to check, start from the region, right? So what is the first region here? For x less than 0, right? For x less than 0, the function f of x is sine x divided by x. So now here, this numerator sine x is a continuous function. We all know, because what is the graphical representation of sine function? This is how we get a sine function without any point of discontinuity, right? So now we all know sine x is a continuous function, and then x, which is a polynomial or a identity function. What is the graphical representation? So this is how we get, right, without any point of discontinuity. So this is our sine and this is our x. So you can write f of x. Here you can take h of x divided by g of x, and we know that if h of x and g of x are continuous, then f of x is a continuous function, right? So here f of x is a continuous function as sin x and x are continuous. Okay, so now for less than 0 the function is continuous. Let me take the other region, that is for x greater than 0, right? If x is greater than 0, f of x is equal to x plus 1, which is a polynomial expression. So x plus 1 is a polynomial expression, hence it is continuous. So now the function is continuous for both the region, that is less than 0 and then greater than 0. So once you are done with the region, now take the specific points. So here at x is equal to 0, let me check the continuity. So now when you are checking the continuity of the function at a specific point, you need to first check LHL, RHL, and then f of x. If all these three are same, then we call the function as a continuous function. So now let me start with LHL, that is limit x to 0 minus x. So here limit x tends to 0 minus 0, the function is sin of x divided by x, right? And that sin limit x tends to 0, sin x by x is always equal to 0, right? So this is a standard formula that we know. So now we can directly take, is not 0, it is actually 1, right? So this here is equal to, we learned it from PU first here. So now what I will do, I will directly take it as 1 here, right? So then you find the limit x tends to 0 plus greater than 1, then it is x plus 1, you make a substitution and you will get 0 plus 1, 1. LHL is equal to RHL, hence is continuous at x is equal to 0, right? So now the function is continuous for less than 0, greater than 0, even at x is equal to 0, and it is a continuous function and there is no point of discontinuity.